Fundamental counting principle homework. And you'll notice there's another homework assignment in the homework page. It's called, I forget what it's called actually. We didn't get to that, and that's totally fine. Yeah, more supercounting. You don't need to do that. We did a little bit of that. Powerball is kind of included in that, but you don't need to look at that homework, the more supercounting. Fundamental counting principle will do just fine. So, Matt, the one that was causing you grief was?
Oh, it wasn't really causing me grief. It was just number E7.
E7.
You had the wrong answer in there.
Yeah.
1600. But I mean, I just figured you made an error, but I was getting the right answer because
Yes,
my calculator couldn't have been that wrong that many times.
No. That goes back to what I was talking about with Kate earlier. The chance of all of us getting the same wrong answer is pretty much zero.
Yeah.
So let's just look at E7 just for practice. Why not? So what we've got here is a combination lock. Many of you have used one of these before, a little 3-digit combination lock. You spin it to clear it, and you go right clockwise to a number. Then you go counterclockwise, I think, past that first number to the second number, and then directly clockwise to the third one. And then it should open. Okay? So anyway, want to just do E5, E6, and E7? Yeah. Want to do all three of them? Why not? It's good practice. So let me grab my eraser, which is somewhere. There's a red rag somewhere, friends. Oh, here it is. Got it. So we've got numbers from 0, available numbers on this lock from 0 to 39. So 35, 36, 37, 39. So you can use any of the numbers from 0 to 39. And I'm pretty sure you can't reuse at least the second and third number. Because let's pretend we don't know that. Because if you think about how you open one of those things, you go to your second number and then you turn to your third one. If your second number was the same as your third one, you couldn't turn. You'd be there already. But let's just forget that for a second. Let's just forget that.
I think you could, because you could turn it all the way around once.
But that would be, yeah.
Plate, it has the,
Yes, that's good. I hadn't thought about that.
I think you can.
Okay, let's for simplicity say we can. For simplicity, we'll say we can. So I put combination in quotes only because it's something we would have talked about later. It's technically not a combination lock. Combination implies that order doesn't matter. But order does matter in a combination. If you put in 1, 2, 3 in your combination 3, 2, 1, it won't open. But nonetheless, forget that. How many different combinations are there per E5?
64,000.
Where did 64,000 come from?
Because it's 42.
We're making a phone number that has how many digits? 3. But we have 40 choices for each of the 3. You see that? Your combination consists of E5. E5. Okay. This is a phone number problem. It's a license plate problem. Can we go right over to that? That'll work. It's a phone number and or license plate problem. It's all the same. Because you're basically taking a string of characters and creating it. Let's do a tree diagram. No. But you could. Your first set of branches would be 40. Right? 0 through 39. And then each of those 40 would have 40. And then each of those 40/40s would have 40. And by the time you're done, you'll have everything from 0, 0, 0 to 39, 39, 39. And a headache. And it would take a long time. How many seconds would it take? We're about to find out. 40 possibilities for the first spin of the number. Also 40 for the second, and last but not least 40 for the third. That's it. It's exactly like the phone number problem or the license plate problem where everything can be reused. Is that believable? Awesome. Boom, boom. So that's where Matty got his 64,000 possible combinations from. So if you forget your combination, that's how many you have to go through. Now, the interesting thing, I think I jokingly mentioned to you, my friend Amy had locked her bike onto down at Mazama, and it's a 4-digit combination, but they only had 10 possibilities each, plus an asterisk. There's an asterisk in there too, so it's 0 through 9 with an asterisk. And she's like, well, let's figure it out. I'm like, well, you got 11 to the 4th power number of ways to do this. You really expect me to do that, do you? And she's like, well, no, I know there's an asterisk somewhere in it. I'm like, good, that's good, because that limits it down, doesn't it? That limits down the number that I have to do. I was like, do you remember anything else about it? She's like, I think it has. She's like, oh wait, it has asterisks and 5s and 8s in it. I'm like, that's it? It has asterisks, 5s, and 8s? And she's like, yeah, that's all. I know that. And I was like, well, that's awesome, because it just went from 11 to the 4th power to 3 to the 4th power. You see that? If there aren't 7s and aren't 2s and aren't 1s and aren't 0s, it's no longer 11 times 11 times 11 times 11. It's 3 times 3 times 3 times 3, which is 81 compared to whatever 11 to the over 10,000. That's significantly less, right? So then we started trying until we found it. Boom, we were done. Does that, see what I'm getting at there, friends? Yeah, Des?
On this question, why couldn't you go like 3 since there's 3 numbers? Or 3
We did.
stuff, and then 2 to the 40th power because there's 40 different numbers.
Why 2 to the 40th?
I mean 3 to the 40th.
Oh, because that makes it seem like there are 40 digits and each, or 40 numbers in the combination, and each of the numbers in the combination has 3 choices. You got it backwards. The spaces indicate how many numbers we have to put into the combination, and the numbers in the spaces indicate the possibilities for each. Does that make sense?
Yeah.
You've got an inverse, kind of.
Yeah.
Ish. I know it's been tough because the phone number example that I started with, there were 10 spaces and 10 options, so there's no way to mess. That's why I start with that one, because there's no way to mess it up. You get the 10 in the right place, but they have to differentiate one like this. Fair? All right, next one, same problem, but we have to have distinct digits. Come back over here for a sec, take a look at it. So same problem, still 3, but we can't have any repeaters. So you can't go 0, 0, 0, or 39, 38, 39, or anything like that. Okay? So, how's that going to change the result, friends?
40, 39.
All right. How many choices for the first number of the combination? 40, still. How about the next one?
39.
Got to be 39 because you can't reuse that one. And last but not... I said 39, didn't I?
Yes.
Okay, good. Went kind of upside down. Okay. Next one?
38.
38, which gives us how many?
59280.
59280. So there's a pretty good chance. Let's put an E6.5 in here. Let's make up an E6.5. Why not? What's the chance, if you've got a master lock like this one, that you've got a combination where all 3 numbers are different?
Between that 1,280 over 64,000?
Unique digits or unique numbers in the combo is going to be that one, 59,280, over that one, 64,000, equals pretty good. It's a pretty good chance, isn't it? It's a pretty good chance.
So that's pretty much what you were asking in number 3.
Exactly, yeah, exactly. Is it unlikely or is it likely? Yeah, for the dice up there versus the combo. Exactly. That's all.
All right.
So I'm asking you, this is good. You're giving me good fodder for the exam one, too. I give you a chance. If I play all 12 songs from the new album, is it unlikely to get every one of them exactly one time? It's the same kind of question.
Yeah.
Take the one where you can't repeat them and divide it by the one where you can repeat them. And then it's either pretty good or not pretty good. Yeah.
Okay.
Anybody have a 3-digit combination lock they use relatively frequently?
Amy's got one.
Are
in
all
the backpack.
all the numbers different?
Yes,
Yeah, mine are too. Mine are down in the Zama too. Pretty good chance. Pretty good chance they're all different according to that. 59,000 over 64,000. 93% chance. There we go. Pretty darn good. Cool. And last but not least, this is the one I think the numerical value was off on about in the answers. How many combinations possible if the first and second numbers must be the same but different than the third? So the first number has to be whatever it is. The second number has to match the first one.
So
And the third one has to be different than both the first two, which is, what are you thinking?
It's 40 times 1 times 39.
I love that. So let's build a lock again. There's your three spots to fill with potential combination numbers. I'm sure you can see this. That's not bad. Okay. So, what number, how many choices do we have for the choice number 1?
40.
It's got to be 40, because you can pick anything. This one has to match that one. So you don't have a choice. There's only one thing to put there, whatever was in the first one. Is that believable? You have to put whatever was there here. So you really don't have a choice. If you put 0 there, 0's got to go there. If you put 2 there, 2's got to go there. One choice alone. How many choices for this guy?
39.
It's got to be different than these two, but those two are the same. So you just can't use whatever that number is. So you've got 39 choices for that one. And this is where I have the answer wrong. Maddie, the answer should be
1560.
1,560. I have written down to 1,600. I'll fix that. Tiff,
Why is it 1, not 40?
because this number has to match this one. So you don't have 40 choices. You have one choice. Whatever this number is, that one has to be the same. So I see what you're saying. You're saying 40, 40. Let's just give me a number for this one, Tiffany. Any number you want to put between 0 and 39 in here. You want to put 30 in here. What number do I have to put here? 30. I have to put the number 30 here. I can't, according to that rule in E7, I have to put the same number here that you put there. So I don't have 40 choices. 40 choices would mean that if you pick 30 here, I could go 30, 0, 31, 32, 30. Was that okay? Oh, okay, I'll stop talking.
It's just your time number.
Don't think of it as the number one. Think of it as you have one choice for what number goes there. I think that might clear up too, but it sounds like you got it. Is that fair, you guys? Is that fair? Right. And look how small that number is compared to these guys. It's exponentially smaller because you're taking basically an exponential base out. That's the point. That's why it was so awesome when it was like, no, it's got asterisks. Wait, it's got 5s. Wait, it's got 8s. And I'm like, wait, where else does it have? And she stopped at that. And I'm like, done. Let's just start trying at that point. Right? The movie The Fugitive, which I know we've talked about before, I think. There's a scene in there where he's on a computer database trying to figure out who the dude was that killed his wife and sent him into running. And he's going through the Google searches. It wasn't Google at the time that The Fugitive came out. But he's going through the database, and he keeps refining his search, and the number of options keeps going down and down and down because he's getting more descriptive in the results that he needs. He's like, oh wait, I need an amputee. So he throws that 300,000 amputee results. Wait, it's an arm amputee, and then recalculates, and now it's only 400. What did I say? Was it 300,000? Now it's 150,000 results. Okay, so an arm amputee. It's the right arm. The right arm. Then half the results go away, and now it's down to 75,000. It's the right arm at the elbow joint, and all of a sudden it goes from 75,000 down to 2,000. And it's a very specific kind of joint. It's this ball joint. All of a sudden it goes from that to 7. The more specific you can be, the fewer results you're going to have. The more specific, the less general. More general to more specific. Does that kind of make sense? And that's the idea. There's an old question that's given on, not IQ exams, but exams like that. What do you think? They list 5 occupations in a row, and they say, which one do you think has the most members, and which one do you think has the least members? And one of the options is secretary, one of the options is female, one of the options is female secretary. And people inevitably say there are more female secretaries than there are secretaries. Well, that can't be true, right? At most, that can't be true. At most, it's the same. Because there are some male secretaries. Hence, I think our Secretary of State, I believe, is a male. Oh, no, wait, no, it's Hillary Clinton. Thank you. So, but anyway, the point is that there are male secretaries somewhere. So as soon as you make it more restrictive, you've gotten the number smaller. Female secretaries has to be a smaller set than secretaries in general, or females in general, because it's a subset of that. And that's what you're doing here. You're making them smaller and smaller and smaller as you go down. Is that believable? That's been a question, Matt.
I got one more question on
Sure.
on number 8.
E8, this guy?
Yeah.
Good.
So I found 4 prefixes.
4 area codes, love
Area
it.
codes. Yeah, 971, 458, 503, 541.
Perfect, 4 area codes.
And so it says, so I did for that, I was a little confused on that because there's two of the area codes start with the same number.
I
right?
love this.
So
I
this
love
is
this.
how you gotta think of this.
You're thinking of it way too fine-tuned.
Damn it.
It's okay, brother. It's okay. He's thinking, this is so easy to do.
Is it just 4, 4, 4, 4?
It's even easier than that.
Really?
It is. It's this problem. Well, I've erased it now, unfortunately. No, it's this problem. It's this problem under here. It's that problem right there. Let's see how, okay? So Matt's asking about this E8. Phone number problem from class, which we had, I said, let's not, Janaea left, we can not do the Janaea correction. All illegal phone numbers are okay. 911s are okay. 000s. Keep it real simple as far as that goes. but I just want to look up area codes that exist in Oregon. So Matty did all the work for us. He found that there were 4 area codes. All right, let's blank that out. Look at this, E8. It's actually a nice combination of this one and E7, believe it or not. What were the area codes again, Matt?
There's 971, 458, 503, and then 541, yeah.
Okay. So here are the area codes.
Camera.
And this is just for, oh, thank you. Awesome, Kurt. There's the area codes that are possible. And I'm just putting them there for reference. I'm still going to make all these phone numbers 10 digits long to show you where the 4 is important, but where the 4 pops in, we're going to see here in a second. Okay, so here's a 10-digit area code, a 10-digit phone number. Okay, there's the first 3, the last 7. Here's the area code out front. Now in class, we filled all of those with 10s. Originally, remember? Because we said, how many area codes? No rules. 000 is valid, 999, all valid area codes. Now I'm saying, no, I want this one to have a 971 area code. How many choices do I have of that first number? 1. It's got to be 9.
So you just do it 4 times?
Yes. That's exactly right.
That's how easy it is.
That's how easy it is, yeah. Remember when we mentioned this in passing in class on Tuesday. I said every time you add an area code, you add how many phone numbers? And who answered? Matt, I think you answered it, didn't you? I think you did. Every time, no, was it Amy? It was somebody right over here. Every time you add an area code, you add 10 million phone numbers. Because watch, there are 10 million phone numbers in this area code, aren't there? Assuming illegal ones. 10, 10, 10. 10, that's the multiplication. 10, 10, 10, 10. That's 10 million, right? That's 10 million area codes. Excuse me, 10 million phone numbers under the 971 area code.
So there's 4 million numbers.
40 million.
40 million.
Right? Because there are also 10 million under this area code, correct? Because the math for this one looks just like the math for that one. And there's also 10 million under 503, and there's also 10 million under 541. So they're all 10 million. So there's 40 million. There's 40 million phone numbers altogether. Every time you add an area, this is a perfect example of that sentiment, Matt. If we were to add a 5th area code to Oregon, 1, 2, 3, you'd pick up 10 million more phone numbers, some of which are really, a big chunk of which are illegal. But nonetheless, you're still picking up an exponential number of phone numbers. Please, Kate.
Would it work to have all those blanks, leave the 10s alone, but for the area code put 444 because you have 4 area codes?
But that gives you 64 area codes, doesn't it?
Yeah, I knew.
I like what you're saying. Can I offer something different? Oh,
Or
this is a good idea. I like this idea. Hold that thought. Yes, but hold that thought. That works numerically, Kate, but it doesn't work contextually. Kate's got a great idea back there. I want to run with it. She says, why don't we just put 411 here? That makes it look like the first digit is one of 4 possibilities and the last 2 are the same, or the last 2 have one choice. For example, if the area codes in Oregon were 541, 641, 741, 841, that's what 4 times 1 times 1 would be, because you'd only be changing the first digit. We can use your idea though beautifully. All we got to do is say, let me move it over here to leave that up. And this is where I could teach this entire course as supercounting, because this is one of those subtleties that we could address. Maybe we should just forget the algebra and just do this the whole time. Yes, one nod. So one way to think of it, Kate, is this: rather than go 10 spaces, do 7 spaces for the phone number, and do 1 space for the number of area codes. So here's the number of area codes, and here's the phone number itself. Is that fair? Because this would still be 10 to the 7th, wouldn't it? And then the number of area codes is just the 4. 40 million. Boom, done all at once. Which is kind of the definition of what we did with distributed property there in the middle board. One way of looking at it, we could have actually done a license plate with that one, couldn't we have?
Yeah.
The license plate from before? When we're moving the block of letters around, just pick how many places can the block of letters go in any of 4 places. And then it's 4 times 10 times 10 times 10 times 26 times 26 times 10. All kinds of cool counting tricks you can do. I don't want to make it seem tricky though. I don't want to make it seem tricky. I'd almost rather you think of it this way we did in the middle here, because that looks identical to everything else we've been doing, and it's less, it might be a little more cumbersome, but at least it's consistent and congruent with the kind of ways we've been looking at stuff. Yes, there we go. Yeah, there it is. There it is. Can I get a yeah? Woohoo! I get a woohoo! That's even better.
Close to a yeah.
Yes, way past you. Good?
Good.
Do you guys want to crunch another Powerball?
No.
No, we got more to eat. We got more to eat. Go ahead, Scott.
I have a question actually about the take-home exam.
Well, that's what I'm saying. The take-home is a Powerball.
Well, more specifically about specific questions. Like,
Well,
can I-
hang on. Time out. You wait. I know you're bigger than me and stronger than me, but you wait.
Probably should have my ass. I'm a wuss.
I don't know. I'm a lot of talk.
Throw a water bottle on you.
I just, well, I'll agree with Marvin, but
I brought my weapon.
should we crank another Powerball probability? And the only reason I bring this up, Scotty, I'm not saying we're going to answer your question, but a big chunk of the exam, I think that take home, I think 20 points of the 50 is crunching through one of those. And I want to make sure that if you guys are unsure about it, we did a couple in class, but I got the sense that it was kind of like, yeah, it's kind of okay, but it's kind of not. You want to do another one? It's up to you. You want to do yes, I hear a yes. A couple yeses. Time out before we go any further. Realize, in class next week is this stuff. This Powerball thing we're about to do, nothing like this is going to be on the in-class part of your exam. Everything on the in-class part of your exam, Linda, use that word as a permutation, which is all about fill in blanks in with digits, possibilities.
Yeah, one more time now. In E7,
Yes.
it's combinations. The question is, how many combinations are possible for the first and second numbers
The same.
if they're the same?
Yes. Which means whatever you put in the first spot has to be in the second spot too. That's why you only have one choice for the second spot. Your second spot has to match the first one. You know what it is? Check this out. This is an easy way of thinking about it. There are no longer 3 numbers on this combination. There are only 2. Because the second one's the same as the first one. So pick the first one, which has 40 choices.
It doesn't matter what the 40 is.
Doesn't matter what it is, there are 40 of them.
40 of them.
And the second one's already been decided, hasn't it? Which means you only have 39 left for the last one because it has to be different. So think of it that way. That might help. There really are only 2 digits. The second one basically mirrors whatever the first one shows.
Right.
Tiffany, did that just make it worse?
Tiffany, did that make it work?
Did that make it worse?
Since you put 40 for the first and second, does the third one have to be 39?
It has to because the rule was it has to be different than the first and second.
Any number, it has to be.
Right, whatever's left besides what's been used in first and second spot. Is that okay? I want to make sure I didn't make it worse.
And that's the same principle for the area code then?
Basically, yes. Except the area codes we have been determined to us. There's no rule that says the first has to be different than the second.
Right.
I did mention one in class, though. The old rules for area codes were, let me think of it now. It had to start, it couldn't start with a 1 or a 0.
Oh,
It
yeah.
had to have a 1 or a 0 in the second spot. And the third spot just had to be different than the first spot.
So in the first example on E8, there's a 111 for that representation.
That's because the number's already determined. It has to be a 9, and then a 7, and then a 1. That's, you have one choice, basically. You have one choice for each of those. Yeah. Cool?
Very
Good. Yes, for sure. Now let me go take a look. I want to make sure I don't redo the exact one I already explained to you on your exam. Let me take a look at the exam real quick. Here we go. Well, no, this one I already walked through. I'm not going to walk through this one again. So the first, oh, we did that one already in class, didn't we?
Yeah.
Oh, no, we didn't. This is 3 of the first 5 in the Powerball. So we didn't do that one in class yet. And I won't do it today because it's done here. You see what I'm getting at here? I'm looking at your take-home exam right now. In class on Tuesday, we went through, I believe, this one, the jackpot.
Yeah.
We went through this one, and I believe we went through this one. Correct? And then we stopped because I had lots of dry
Last
heat.
one we did was 4 out of 5.
4 out of 5 plus Powerball.
No Powerball.
4 or 5 without.
Oh, we did without Powerball. Okay, so we did this one actually. We didn't do that one. Are you sure?
No, we did that
We
one.
did that one.
Right, we didn't do this one. We didn't do
No.
4 to 5 without the Powerball. Want to start with that one today?
Sure.
Because what I have, this one is explained to you in the exam right below. This case right here, watch, I'll show you. This one right here, get 3 of the first 5 numbers and the Powerball. That means you hit 3 of the numbers and you get 2 wrong, and you hit the Powerball. So I won't do that one, obviously, because it's right there explained for you. I'd rather not replicate something you've already seen. Does that make sense? Or you're going to see, because it makes less sense. It makes more sense to do more different examples. And the one I'm going to ask you to do is,
Yeah, you asked for more Powerball questions.
but not getting the, oh, is that what we did in class? So we're not going to do that one either. This is 4 and not the Powerball. So I'm asking you, for the 20-point question on your exam, I'm asking you to do this one right here. So I'm asking you to show me why it's 1 in 19,000.